Why circle is 360 degrees? Why not something simpler like 10 degrees or 100 degrees? It's a curious question. If you're one of those humans who loves math, a question that has surely nagged you at some point. All the calculations would have been so simple, wouldn't that be more convenient? Believe it or not, 360 is actually the ideal solution. A number like 10 or 100 would have been more inconvenient, mathematically speaking. You see, the number 360 is divisible by every number from 1 to 10, aside from 7. It actually divides into 24 different numbers: 1, 2, 3, 4, 5, 6, 8, 9, 10, 12, 15, 18, 20, 24, 30, 36, 40, 45, 60, 72, 90, 120, 180, and 360 itself. These 24 numbers are called the divisors of the number 360. This is the highest number of divisors for any positive whole number up to its own value of 360. For example, the number you might assume would be most convenient for the full circle, such as 100, has only 9 divisors. Numbers are said to be highly composite if they are positive integers with more divisors than any smaller positive integer has. The only highly composite numbers below 360 are 2, 6, 12, 60, and 120. Highly composite numbers are considered good base numbers with which to perform common calculations. For example, 360 can be divided into 2, 3, and 4 parts, and the resulting number is a whole number. The resulting numbers are 180, 120, and 90. However, dividing 100 by 3 doesn't end in a whole number. Instead, it provides a decimal value of 33.3 recurring, which makes performing calculations much more difficult. Calculations using 360 are quite simple once you become used to them. One theory for why a full circle is 360 degrees comes from the Babylonians. The Sumerians and Babylonians used the sexagesimal numeral system, a system with a base value of 60, while the current system we use is known as the decimal system and has a base value of 10. So, once we reach the 10th number, we start repeating the symbols of previous numbers, from 0 to 9, to form new numbers. The Babylonians had 60 different symbols with which they formed numbers. Again, why would they use 60? Because 60, just like 360, is a highly composite number with up to 12 factors. Just as we can count 10 on our fingers for the decimal system, we can also count to 60. Start by counting the knuckles of the 4 fingers, not the thumb, on your right hand. 12, right. Now, on the other hand, raise any of those fingers to note that you finished one iteration and got the number 12. Now, repeat the same procedure as many times as the number of fingers remaining on the left hand. The number you will end up with is 12 knuckles x 5 fingers equals 60. Now, to tie this all together, if we were to draw an equilateral triangle with the length of sides equal to the radii of a circle and place one of its vertices at the center of the circle, then we could fit a total of 6 such equilateral triangles inside a circle. Since the Babylonians used the sexagesimal numeral system, they considered each triangle to have a base value of 60. Thus, 6 triangles x 60 base value again gives us a value of 360. In many different geometric applications and historical records, the number 360 has been a useful and powerful tool, And while we may count on the decimal system for most of our calculations and measurements, the sexagesimal system is far from forgotten.